Welcome to Business Analytics 2. My name is Professor Davier. I'll talk a little bit about the course, but before we do that, I want to talk about what business analytics is, how it's defined, and what it means to businesses and to your career. Business analytics is about gaining knowledge and insight from data using statistical analysis, quantitative methods, and mathematical or computer-based models to help managers make better, fact-based decisions. Let's break that down for a second. That middle chunk there, from data to computer-based models, is really talking about how we are going to go from data to insights. To get there, we're going to use statistical analysis, we're going to use quantitative methods, and we're going to use mathematical and computer-based models. These are the tools to turn data into insights. Why are we doing that? Well, the goal is to help managers make better fact-based decisions. We are not doing analytics just for analytics' sake. We are doing analytics to help guide a business, to help optimize some outcome, and to help managers make more of the resources that they have available to them. It is important that managers understand what their data science team is reporting and how to interpret it. There are several cases, even in very big companies, where wrong and costly decisions have been made because the managers couldn't understand properly the data science reports. Let's talk about the scope of business analytics. Analytics tends to take on one of three flavors, and this is definitely a spectrum, so there is some gray area in there as well. First, there is descriptive analytics. Descriptive analytics uses data to understand past and present behaviors. We actually used to only be able to analyze past data, but with modern technologies, we can also use descriptive analytics to understand what is happening in real time, what's happening right now. To do this, we're going to get our data, and we are going to analyze the behavior of one or more variables. The goal is to understand how they move, and in the case of several variables, how they move together. For instance, we can look at how sales change with price. Predictive analytics builds on descriptive analytics, and it says that if we understand those relationships very well, we've done a good job doing descriptive analytics, then we should be able to predict outcomes. With predictive analytics, we're going to analyze past data to forecast future outcomes. In that case, we can try to predict, for instance, how much we will sell at the current price. Finally, prescriptive analytics builds on that and says, well, if we can accurately predict what's likely to happen in the future, then how can we set ourselves up best for success? It's going to use optimization techniques to make decisions. For instance, we can attempt to find what the best price is to maximize profit given the expected sales at this price. Analytics is also the foundation supporting a whole world of wonders that includes artificial intelligence and automation, such as algorithm creating videos, songs, or writing article on your favorite website. But it's also the foundation of statistical experimentation, which focuses on the best ways to collect data to allow us to draw causal conclusions. Let's make that real and look at an example of how this gets applied. Our example is going to be simply a retailer trying to figure out when to advertise and when to offer discounts to clear seasonal inventory. Every retailer has to do this every season to get rid of whatever is going out of style, and they'll advertise and discount to do that. Descriptive analytics would simply say, let's look at historical data for similar products. We'll look at the prices at which they sold and how much they sold depending on the price. This is done to understand what's the relationship between price and quantity sold. We'll also look at, in a similar way, the relationship between advertising and the quantity sold, given the price. Predictive analytics would then take that and say, well, if we understand those relationships, let's predict sales based on a given price and advertising level. Let's build a model that allows us to predict what sales will be given our advertising schedule and our discounting schedule. Finally, prescriptive analytics would look at this and say if we can accurately predict that, if we know what sales are going to be given the advertising and discounting schedules, well, what's the optimal discounting schedules and what's the optimal advertising schedule to maximize our future profits? So each of these steps is going to build on the previous steps, and we're going to now talk about how this gets used in various industries. What I've put up on the slide right now are really the firms that are known for these different aspects of business analytics. If we think about Amazon.com, their core product in terms of being a digital retailer really stemmed from being able to recommend products efficiently. When you log on to Amazon.com, you see something that's likely very, very different than what I see when I log in terms of the product assortments that they're showing to you and in terms of the ads. What that allows Amazon to do is to carry a near infinite number of products without having their consumers digging through a never-ending inventory to find what they might need. They're able to carry a wide array of products while minimizing search costs for consumers. Meta, including Facebook and Instagram, is another example. They use business analytics to determine whom each ad should go to. If they can find the right user for an ad, advertisers will want to pay more to show their ads on the platform, and that's where they really make their money. Netflix is also an interesting example. Netflix took the data that they had and they used it not only to recommend shows for people to watch, but they actually started building shows based on their analytics. House of Cards was probably the earliest example of this. House of Cards was originally in Britain, and it came to the US and it was shopped around to various movie studios and was being turned down quite a bit. Then it went to Netflix, and their chief data officer at Netflix said, well, people on our platform have an appetite for political dramas, and if we can do this right, I think it could be a hit. What he meant by right was looking at the shows that people watched, whether they finished them, whether they finished the series, and how quickly they do that, and what those shows' attributes are, of course. What they found is that for the audience at that time, there was a lot of demand for a director, David Finch, and for an actor, Kevin Spacey, and then for political dramas. So they put all three of those together to make House of Cards, and that's how it got launched to great success in the early years. Finally, we also have some examples of where maybe business analytics doesn't work out great because the data is given prioritization over empathy and over a real understanding of what's going on. A great example of that is written up in Forbes about what happened at Target. Target likes to find out moments where they can strengthen their relationship with their customers. One of these moments is when someone finds out that they are expecting. When people find out that they are expecting, especially their first child, they realize that they need to buy a lot of things, but they don't necessarily know what those things are or how to evaluate whether each thing is good or bad. They usually don't know much about baby strollers or car seats or diapers or baby formula, any of that. For Target, this is an enormous opportunity to really help the customer navigate that process and then become a trust retailer on that front. Target set their data science team and said, hey, can you help us predict when someone has found that they are expecting? Their data science team was able to do this by looking at a combination of products that are frequently purchased by people when they first find out that they are expecting. Then Target took that and said, well, let's do some prescriptive analytics and let's send flyers on these individuals. And those flyers will advertise things like diapers, baby formulas, strollers to help guide their decision-making process. It will be wonderful. We'll put a nice front page on the flyer with a baby and a stroller. And they started sending this out, and then they ran into a bit of a problem. That problem was that a father came into the store, one of their retail outlets, and asked to speak to the manager and proceeded to berate him very loudly, yell at him. How dare you send this flyer to my daughter? She is just a teenage daughter. Discussion ultimately ends and the father leaves the store, and then he calls back a few days later to apologize because there were things going on under his roof about which he was unaware. So what happened? What happened is that Target effectively and accurately predicted that this girl was pregnant, and as designed by their business processes, they sent her a flyer full of products that she could buy. In doing so, they outed her to her family. They effectively shared private information about one of their customers that she may have felt better keeping private for a while at least. And so they had to take a step back at that point. They recognized that obviously that wasn't good and that they forgot about the human side. What did they do? Well, they said, we don't want to stop sending these flyers. They are very useful. This is a huge opportunity for us to help customers and to do those things, but we don't want to out our customers either. So instead, they still run these data science models. They still try to predict when people find out that they are expecting, and they still send them advertisements. But now, those advertisements don't have a stroller or a baby on the front. They're just a fairly standard set of products that they have. But the coupons and the products inside are determined by shopping behaviors. So instead of just having baby bottles and formulas and car seats, it might have also wine glasses and television next to the car seat so that it doesn't out the person. All of those products are still in there, but it's not making it as obvious to the customer or to others in their household why they are being targeted. There are many examples where business analytics can help, but we have to be careful and never blindly let the data lead the decision-making process without thinking about the implications of our actions. Why does this all matter to you? Why should you care about business analytics? To put it bluntly, it's for the success of your career at this point. I have a couple of different data points here on the slide about the growth in analytics jobs. Basically, starting in the early 2010s, we saw an exponential growth in job postings for data science. The market is largely dominated by two types of jobs, the one using the R programming language and the ones using Python. Now, recently the number of Python jobs grew even more because Python is also used for machine learning and artificial intelligence. But for standard analytics, R is usually considered easier to use and more adapted. Looking at how those jobs are growing, well, the average job in the US is expected to grow 7% between 2016 and 2026. In terms of the number of positions, for financial analysts, that number is 11%, so about 1.5 times the US average. For management analysts, it's 14%. For market research analysts, 23%, so over 3 times faster than the US average. Operation research analysts are growing at a rate almost 4 times the US average. So on the previous slide, I showed you firms that have figured out how to turn business analytics into a competitive advantage, how to use it to create value for the firm. But what they need now, they are people that are trained to do this. There is a huge demand for those people, and that's spelled out by the job growth that we've seen. Business analytics is an incredible opportunity to succeed in your career. If you want to be an analyst, there is a lot of job growth. But even if you don't want to be an analyst, you're still going to be a consumer of business analytics. You are still going to have to make decisions based on analytics and data science, which means that you need to be fluent in these areas. You need to be able to understand how to read and review business analytics work and how to base your decisions on it. So even if you don't plan to be an analyst, understanding analytics is going to be vitally important for the success of your career. To conclude, let me introduce myself. I worked in digital marketing and IT consulting before going back to study, specifically because I needed more quantitative and analytics skills. I did a Master of Economics and then a PhD in Economics at the University of Toronto, where I specialized in econometrics and statistical computing. I then did a postdoc in marketing at Wharton and taught the course on business experiments to the MBAs there. I finally joined the University of Wisconsin because they are leading the world of business education in terms of business analytics, with notably the creation of a very successful Master of Business Analytics program. My research interests are heavily focused on analytics with the goal of gaining insights from data and advancing data-driven optimization and automation. I use a lot of machine learning methods and computational statistics, including artificial intelligence models. I combine analytics with insights from psychology, sociology, neuroscience, and genomics to understand consumer behavior and improve personalization. There are multiple applications for that, including digital advertising, social networks analysis, product development, and consumer behavior prediction. I'll be happy to talk more about that, and feel free to contact me if you want to talk about this. But for now, I'll conclude the video, and in the next one, we will talk about the course organization.